Hello everyone, welcome to my YouTube channel. In today's class, I will explain traveling salesperson using branch and bounding in the subject of design and analysis of algorithm. Okay, here first if you see what is the meaning of traveling salesperson, what are the rules? Okay, here a traveling salesperson, it is a problem. Here we have to take some set of cities. The traveling salesperson has to visit each and every city at least one time, and he does not visit any city more than once. Okay, he has to visit for business purpose only one time. When you are going for a city on business purpose, you have to complete the entire task only first attempt only. Okay, if you visit again and again, means the cost will be increased. So here does not visit any city more than once. And the next one is the starting city and ending city should be same. The starting city and ending city should be same. For example, we have four cities A, B, C, D. Okay, assume these are the four cities. You are starting from A to B, and B to we visited C and C to D, and finally where is the next where is the original location A, so we have to visit A. Okay, like that we have to complete all the cities only one time. But here what is the problem here? Which path if you select, it will cover with less cost. That has to find out here. Okay, ఏ రూట్ లో మనం వెళ్తే తక్కువ ప్రైస్ లో అన్ని సిటీస్ కవర్ చేస్తాం అనేది మనం చెక్ చేయాలి. Here in traveling salesperson in branch and bound, these are the conditions. Here I am taking four cities. The four cities are A, B, C, D are the four cities, and A, B, C, D are four cities. Here I am taking the four cities values are like this. If a person A to A, if you visit at A to A means the cost is 0. A, B to B, the cost is 0. C to C cost is 0. And C to E cost is 0. Next, what is the remaining values? A to B traveling, the cost is 10. A to C traveling cost is 5. A to D traveling cost is 3. Like that, remaining all the values. Okay, now before starting the problem, here the first step is step 1 is row reduction. Okay, here the first step is row reduction. Here what is the rules? What is the rules here to perform the row reduction? I have to check all the row or column should contains infinity, then no need to perform the reduction. Okay, all the row. Okay, here for row reduction you have to check any row. Sorry, initially we have to perform the row reduction with minimum element. Okay, here in this row, what is the minimum element is 3 is the minimum element. Here the minimum element is 7. Here the minimum element is 1. Here the minimum element is 2. Okay, with this value you have to reduce. This is the minimum element. With this minimum element value you have to reduce the row reduction. Okay, after performing row reduction, what is the value here? Infinity. 10 minus 3 is 7, 2 and 0. Here perform the row reduction with 7. So 8 minus 7 is 1. Infinity. 9 minus 7 2. 7 minus 7 is 0. Next here 1 minus 1 is 0. 6 minus 5 infinity, and here 8. And what about here 2? 2 minus 2 is 0. Here 2 minus 3 is 1. 2 minus 8 is 6. It is infinity. So this is the row reduction value. Okay, and what is the total row reduction value? The cost is 3 plus 7 is 10. 10 plus 1 is 2, and total cost is 13. Row reduction value is 13. And step 2, column reduction. Okay, step 2 is column reduction matrix. Okay, it is row reduction matrix, it is column reduction matrix. Okay, which one I have to take? I have to take the after perform the row reduction that I have to perform. Okay, here column reduction matrix. Okay, again here column reduction matrix. Okay, what is the values here? Minimum value is, this minimum value is 1. This minimum value is, sorry, here minimum value is 0. Here minimum value is 1. Here minimum value is 2. Here minimum value is 0. So, with this value, you have to perform the row reduction. Okay, what is the total value here? Total row reduction or column reduction is 3. Okay, next total column reduction is 3. So, what is the final matrix? We'll get infinity. Okay, here 1 minus 7, so 6. Here 2 minus 2 is 0, and here 0, 0, 0. Like that we have to calculate here. 1 minus 1, 1, 0, 0, row matrix. Okay, here 1. So 6, here infinity, and what about here? 1 minus 5, 4. 1 minus 1 is 0. Here 2, we have to reduce to 2, 2, 0, 0, infinity, 4. Here also 0, 0, 0, 8, infinity. It is the column matrix. It is the column reduction matrix. So, in row reduction equals to what is the value? 13. And column reduction equals to what is the value? Column reduction equals to 3. So, total reduction. What is the total reduction we have? Total reduction is 16. Total reduction is 16. Let's consider this matrix as M1. Let's consider this matrix as M1. From A, we have a chance either to go or B, or C, or D. So, if we have to go in, A to B, A to C, A to D. What is the cost? We have to find out. Okay, we have to travel from A to B. A to B, we have to travel. A to C, we have to travel. A to D. So, we are finding A to B, A to C, A to D first. Okay, according to this M1 matrix. According to this M1 matrix. Okay, see here. Whichever path is easy or giving low cost, who have to go in that path. Okay, what is the main aim here? To find out the shortest path. So, whichever will give that will go A to B to C to D. So, here A to B and D value. Okay, here A value is, total reduction value is 16. Okay, we have to find out these values first. Okay, next A to B. First I am finding here A to B cost. I am finding A to B cost. Okay, when you are finding A to B cost, complete A row is infinity, comma. What is the column here? B column is infinity, and B to A path also infinity. B to A path also infinity. Remaining values from M1. Okay, remaining values from M1. So here I am taking here infinity, A row is infinity. So infinity, 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 infinity. B column is infinity. And B to A is infinity. B to A is infinity. Remaining values are from M1. Okay, if you are taking M1 means what is the value here? 0, 0. So it is 0, 0, here 0, here infinity, here 8, here also 0, here 4, it is infinity. Remaining values from M1. So after taking from M1, we got these values. Okay, see here, this is the A to B matrix. Okay, now what I have to do? The reduction of parent matrix is 16. Okay, here reduction. What is the previous reduction value? Reduction of parent matrix is equals to 16. Now we have to reduce these matrix values again. Now we have to reduce these matrix values. How to reduce? We have to check every row and column. Previously, in parent matrix, we have reduced column and row matrix and column matrix at a time. But here we have to check some conditions. What have to check? All the rows or column should be contained. Sorry, should be infinity. Then no need to check. Or at least one value in row or column should be 0. Okay, at least one row or column value should be 0. So there is reduction is 0. Okay, either this condition or this condition is satisfied, then there is no reduction. So reduction is 0. So total cost of A B is equals to cost of, this is the formula. Total cost of AB is cost of parent matrix plus reduction plus A to B parent matrix. Okay. Okay. Here what is the total parent matrix cost? The cost of total parent matrix is what? 16. Here we have to check. Here this entire row is 0. So no reduction. Here 0 is available. So no. Here also 0 is available. Here also 0 is available. And here 0 is available. Here entire row column is infinity. So no need to reduction. Here also 0 is available. Here also 0. So here total matrix is, here total reduction is 0. So reduction is 0 plus A to B path value. A to B path value in parent matrix, not here. Okay, in parent matrix A to B path value is 6. So here we are taking A to B is 6. So what is the total cost here? The total cost is 22. To travel A to B, the cost is 22. So I have to update the diagram. Here parent total reduction is 16. A to B cost is 22. Like that, we have to find out A to C, and we have to find out A to C as well as A to D. Okay. For time being, I am doing this two in offline. For time being, I am doing this A to C and A to D in offline, and I will show in this video. Yeah. Now A to C. What is A to C here? In the A to C, we have to take A row is infinity values and C column as infinity values and C to A is infinity column. Okay, according to these conditions, remaining values we have to take from the M1 matrix. Okay, A row A column is infinity, all the infinities. C column is infinity and C to A is previous M1 matrix. So C to A value is infinity. So remaining all the values we have to take from the M1 matrix. Okay, after taking these values, I have to check two conditions. What? The entire row should be infinity or any value should be 0. Then there is no reduction. Here all infinities, there is no reduction. Here 0 is available, so no reduction. Here there is no all infinities, and also there is no 0 value. So we have to perform reduction here. Okay. What about last column? Here 0 is available, so it is also valid. Okay, what is the least value to perform the reduction? The least value is 4. With a 4, we have to do reduction. Okay, after reduction, we are getting in the place of 4 and 8, we are getting minus 4 means 0, and it is 4. It is the 4. Okay. Okay, it is the 4th. So again, we have to check after row reduction. We have to check the column reduction. Here 0 is available, no need. Here also 0 is available, no need. Here also all infinities, so is okay. It is 0 is available, that's okay. So what is the total cost value? Total cost formula is total cost equals to cost of parent plus reduction of this value plus A to C path. Okay, here what is the total cost? Parent of the total cost is 16 plus what is the total reduction here? 4 plus 0, so only 4. And what is the parent A to C path is 0. Okay, in the M1 matrix A to C path is 0. So what is the total value is 20. Now we have to update here the A to C value is 20, and same like that we have to find out A to D. What is that? A to D. If we are taking A to D means what? I have to take A to A row is infinity, D column is infinity, and D to A path is infinity. Okay, same like that we have to check all the rows. There is no here our condition is satisfying. All the infinities are either 0. Here all infinities 0, here also 0, here also 0. So no reduction. Not about column here also. 0 is available, 0 is available, 0 is available. Here all the infinities. So it is no end. So what is the total reduction is 0. Okay, total reduction is 0. Total cost equals to total cost of parent plus total reduction plus and D to A path. So total value is 16. So again we have to update the diagram here. A to D cost is 16. By comparing these three, okay, I am writing here A to B cost is A to C and A to D cost is, here A is 16, here up to B cost is 22, here C cost is 20 and D cost is 16. Among these subproblems, which one will get least value? We will follow the rule. Here 16 is least, so we have to travel in this path. Okay, we have to travel in this path. So we are traveling from A to D is okay. The cost is 16. And what about the remaining paths? We have to again path travel D to B and D to C. We have to visit these two people. Okay. And here up to A to D is considered. A to D is considered. Okay. A to D. Okay. And what about to B? That is called A to D to C. A to D to B we have to find out. And as well as A to D. Okay. A to B is okay. A to D and up to C. These two equations again we have to find out like these methods. Like same as A to C. Like that we have to find out the A to D to B, A to D to C we have to find out. Okay, for time being I am doing on offline. Here in this diagram we are considering A to D. So A to D is least cost. So we are considering A to D path. So here what is the A to D value? That becomes as M2 matrix. That becomes as the M2 matrix. Which one is considering? That has to be become as the M2 matrix. Now we have to find out A to D to B, A to D to C. Okay. See here. For A to D to B, here what you have to take? A to D to B, you have to take A row value, D row value is infinities, B column value is infinities, and B to D and B to A, thus those paths are the infinities. Remaining values from M2 matrix. Okay. Remaining values M2 matrix. So here A row is infinity. Okay. D row is same. A row and D row same. And B column and same. Okay. From previous same values. Sorry, all the infinities. A row, D row infinities, B column is infinity. Remaining from M2 matrix. Okay. Now we are checking for reduction, row reduction. Here all infinities, there is no. Here 0 is available, so no problem. Here also 0 is available, no problem. Here also all infinities, no problem. So what about column infinities? It is 0 is available, no problem. All infinities 0 and 0. So there is no reduction. Reduction is 0. So what is the formula here? Total cost equals to parent reduction plus D to B path. Okay, here parent is 16, 0. Here D to B is 0. So what is the total cost is 16. Okay, next. What is the second term? A to D to C. Okay, next here. A, D rows are infinities. C column is infinity and C to D and C to A is path is infinity. Remaining from M2 matrix. Okay, if you are writing like that, you will getting these values. We are checking the reduction. Okay, here all infinity, no need to reduction. Here also, here there is one value only, there is no 0. So it is reduced with minus reduced with 1 value, and it is also reduced with 4. Why? Because there is no 0. Okay, and it is okay. Okay, after reducing row reduction infinity, 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 infinity. Here 0, infinity, infinity, infinity. Here infinity, 0, infinity, 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 infinity. And what about column and row reduction? There is no need to column reduction. All the satisfying. So what is the total reduction here? Total reduction is 5. Total reduction is 5. So total cost is 16 parent reduction plus here reduction is 5 and D2C path is 4. So total cost is 25. Now we completed this work. And what about the next diagram? The diagram is A, B, C, D. Okay, here B value A to B is 23. Here C value is 20. Here D value is 16. Okay, it is C value 16. Then that's why we are extended here D to B, D to C. What is the here the cost is 16. Okay, and what about this one? Here the 25. So comparing B and C, 16 and 25. Which one is the least value? 16 is the least value. So we are extending this to find out C value. We have to find out. We travel from A to B, sorry, A to D, D to B, and D to C. So we have to find out the path for A to D to B to C. For this one, we have to find out the value. Okay. For time being, I am doing it offline. This equation, and later I will explain. Okay, here in this one, last one, where we consider, okay, where by comparing here B and C, the value is, it is the least value. So D to B value has to taking as the M3. So here it has to take M3. This matrix has to consider as M3 matrix. Why? Because here we are considering the B to, sorry, A to D to B is the least value. So we are considering this. So it is becomes the M3 matrix. Now we have to calculate A to D to B, B to C. We have to calculate this one. Okay, I have to calculate this. This one means we have to take the values A, D, B. These three rows are the infinity, and C column is infinity, and C to A path, C to D path, C to B path values are infinity. The remaining values from the M3 matrix. According to these conditions, if you write, we will get the values, the matrix values is all the infinities. So here the check the conditions to reduction. Here all the infinities, here all also for everywhere all the infinities. So no need to reduction. So what is the reduction value is 0. And what about the total cost? The total cost equals to parent cost plus reduction plus B to C path, B to C path. So 16 plus 0 plus B to C plus 0 from M3 matrix. So what is the total cost is 16. So what is the path diagram? The path diagram is here. We will update this matrix only. Here the B to C path also 16. Okay, B to C is also 16. Now we have to travel A. We have to travel A. Okay. Next, what is the path diagram? Here we have to travel A, but we won't draw the diagram for C to A. Okay, we'll write it in the directly. Okay, here what's the path diagram here? So path is A to B and D to B, B to C, and again we have to reach A. So A. So according to the matrix values, A to B value is 3. D to B value is 3. B to C value is 9, and C to A value is 1. So what is total cost? Total cost is 3 plus 3 plus 9 plus 1. That equals to 16. So, according to our example, if a person has to travel from traveling salesperson from A to B, sorry, A to D, D to B, B to C, C to A, then he will get the total cost is 16. The total cost is 16. Okay. Here, how we are writing these values means the input values. See the input values here. A to D value is 3. A to D value is 3. And B to B value. D to B value. D to B value is 3. So 3. And B to C value. B to C value is 9. And C to A value is 1. So according to this, we have to take in these values. The total cost is 16. Okay. Thank you everyone. This is about the traveling salesperson problem using branch and bound. If you have any doubts, please ask me in comment section. Please like our YouTube, our videos, and share with your friends also. Thank you everyone.